Okay, so let's initially talk about, we're going to talk about ions, so we can make ionic compounds. So an ion is simply a charged particle. And we're going to have two types of charged particles, or charged ions. The first are cations, and cations are positively charged ions. And then we have anions, which are negatively charged ions. Okay, so ionic compounds that we're going to make or that are formed in chemistry are compounds that contain cations and anions. An ionic bond is formed between positively charged cations and negatively charged anions. It's the attractive force that exists between oppositely charged particles. That's what an ionic bond is. Ionic compounds are often called salts. One of the salts we know is table salts, which we'll talk about here shortly. But when you have a compound that's formed from cations and anions, it's an ionic compound. It's also called a salt. We're initially going to talk about ions that come from single atoms, which are called monatomic ions. But there are going to be polyatomic ions, which we'll talk a little bit about later. So ions are formed when atoms either lose or gain electrons. Remember, the electrons are kind of on the outside of the atom while the nucleus is in the middle. The nucleus is not what we're going to deal with, so we're not going to gain and lose protons because that would actually change the elements. So when we're talking chemistry and chemical reactions, it has to do with the electrons. So to form ions, an atom is either going to gain or lose electrons. So if you think about an atom, atoms are neutral. They have the same number of protons as electrons. If that atom gains some more electrons, that means it's got more electrons than protons. It's got more negative charges. So now it's going to be negatively charged. It's not an atom anymore, it's an ion. It's a negatively charged ion, and it's called an anion. Nonmetals are the elements that are going to form anions. Nonmetals are going to gain electrons to form anions. Okay? On the opposite side, if your atom loses electrons, it then has more protons than electrons, and it's therefore positively. It's a positively charged ion. It's not an atom anymore, it's an ion, because it's not neutral anymore. And positively charged ions are called cations. And the elements that are going to form cations are the metals. Okay, so metal atoms are going to lose electrons to form cations, and nonmetal atoms are going to gain electrons to form anions. An example is this one here, where we have sodium metal. You can see sodium metal right here, and chlorine, a chlorine atom. The sodium atom has 11 protons, 11 electrons. And the chlorine atom has 17 electrons and 17 protons. They're neutral, right? If we look, sodium's an alkali metal. It's in the first column of the periodic table. It's got 1 valence electron. Chlorine is a halogen. It's the column right next to the noble gases. It has 7 valence electrons. What's going to happen when I bring these two atoms together is an electron from the sodium atom is going to be taken by the chlorine atom. So the sodium is going to lose an electron. Therefore, it's going to have more protons than electrons. And it's going to become a positively charged ion. And we can see we put that positive charge in the upper right corner, so it's superscripted right after the symbol. Chlorine is going to gain that electron, so it's going to have more electrons than protons. And chlorine is going to be a negatively charged ion, and we put that charge in the upper right-hand corner again. Now, we're going to see that these charges can be, positive 1, positive 2, positive 3, or negative 1, negative 2, negative 3. And that little positive sign, if it's more than 1, we're going to have a 2 in front of the positive sign, or a 3, or whatever. Okay, same thing with the negative. If it's only 1, if the difference between protons and electrons is only 1, we just put a plus. We don't put a 1 plus, we just write a plus. Same thing with the negative. If the negative charge is just a negative 1, we just put a negative. We don't put a 1 with the negative. So if you just see a negative or a positive, you can assume that's just a 1 plus or 1 minus. So the difference between protons and electrons would be 1. So when you form a series of these, if we have a series of sodium atoms and chlorine atoms, and they interact and they become ions, those ions stick together in a form like this, and that's actually a crystal. But it's an array of positive and negatively charged ions that are kind of dispersed there, where I have a positive ion and a negative ion, right? We've got a negative ion, a positive ion, a negative ion, a positive ion, and so on. And that's what happens when you form ions. Ionic bonds form because of the attraction between the negative ions and the positive ions, the anions and the cations, and that's what holds those together. Also notice in this structure, for every 1 sodium ion, I have 1 chlorine ion. Okay, so if I look around here, there's the same number of sodium ions as there are chlorine ions. So, like I just said, 2 oppositely charged ions will attract each other, and that force that occurs between them, that attraction, is what's known as an ionic bond. So ionic bonds are formed between oppositely charged ions. If we go a little bit further, and I try to put 2 cations together, they're both positively charged, so they actually repel each other. Or if I try to put 2 anions together, they're negatively charged, so they will repel each other. Okay. One of the fundamental rules in chemistry is that opposite charges are attracted to each other, and like charges repel each other. So when we make ionic compounds, or when ionic compounds are formed, the overall compound is neutral, meaning that there's the same number of positive charges and negative charges. So we'll look at this a little bit further here going forward, but overall, that structure is neutral, right? So it's got the same number of positive and negative charges. When we do that, that's how we're going to figure out their formulas and their names and stuff like that. So the last sentence here, I've got sodium ions that have a single positive charge, and chlorine ions that have a single negative charge. When I put them together, I get Na plus and Cl minus, and you can see that the charges would cancel each other out if the two were together. So I overall get what I would write is NaCl as the formula, understanding that they are ions, Na positive and Cl minus. But when I write a formula for an ionic compound, I want to write it so that it's neutral. So they have the same number of positive charges from the cations and negative charges from the anions. And that's how we come up with this formula for our ionic compounds. NaCl is called table salt. That's the salt we use on our foods primarily. Okay. One thing we really need to stress is that that ionic compound is very different, has very different properties than the atoms it came from. Okay, sodium atoms, sodium metal, is very reactive. It's reactive towards water, violently reactive towards water. And chlorine gas is kind of this yellowish greenish gas that's toxic to humans. So as elements, as atoms, sodium and chlorine are not good for humans. However, when I allow them to react and form ions, sodium ions and chloride ions, those are necessary elements or ions in our body. We need a certain amount of sodium and a certain amount of chlorine for our body to work properly. So ions are very different from their atom counterparts. Okay, so that's the beginning of chapter 3, and we'll go on from there.